Hello friends, this video on electrochemistry part 31 is brought to you by examfear.com. No more fear from exam. Now we'll start a very critical topic called batteries. What are batteries? Batteries are galvanic cells or set of galvanic cells connected in series, and we can use them for source of electrical energy. Correct? And they are nothing but set of galvanic cell in series. They are connected in series, and we use them as source of power in our home. And in all these, generally chemical energy is converted into electrical energy, right? For example, in our laptops, in my mobiles, in my clocks, inverter, this is in my car, all these places we use this battery, right? There are two type of battery actually. They are primary battery and secondary battery. So before we even go to the types of battery, let's see what are the wish list. What do we want in batteries? When we buy a battery, we generally buy for our torch, for our laptops. So for a battery to be of practical use in our day-to-day life, it should be light, it should not be very heavy, it should be compact, you can carry it. Its voltage should not drop during its use. Right? It should not be that when I bought this battery it was 2 volt and after 1 month it became 1.5 volt, right? Because in that case the electronic device where I'm connecting this battery to will not work. It should be rechargeable if possible. It should last longer. If I buy, I should not keep changing my battery daily. If I just fix a battery, it should work at least for a year or 6 months. It should be less. It should create less environment pollution. Generally, batteries, if you see, they have chemicals, and these chemicals also create environment pollution. So we want these batteries to be environment friendly, right? And also, it should be easily disposable. It's not that I just bought the battery and I want to dispose it. I can't dispose. It should not be very poisonous, right? It should be something which can easily be disposed. So these are the basic wish list that we are looking for in a given battery. For example, when you buy a lithium-ion battery, it has almost all these features. When you buy a battery from our watch, it has almost all the features except that rechargeable part. When we buy the battery for the inverters or the battery which we use in a car, the lead battery, actually the lead battery, we'll discuss more about this. It has almost all the features that we are looking for, right? Depending on the type of requirement, whether you want rechargeable or not, what is the size of battery you are looking for, we have different kind of batteries in the market. Right? And as I told, there are two different type of batteries, primary battery and secondary batteries. So primary batteries are generally, as the name suggests, primary, single use. They are single use battery. That is use and throw. Use it, once it is dead, dispose it. Right? For example, the batteries which is used in clocks, watches, calculators, we use primary battery. Secondary batteries are rechargeable batteries. You can use it second time, right? Rechargeable. They are rechargeable battery, right? For example, lead acid batteries, lithium-ion batteries that is used in mobile phones, laptops, they are all rechargeable batteries. You can recharge them again and again. Let's understand these kind of batteries in details, right? The primary batteries. So let's see the primary batteries. So they are batteries which are used once, right? And once it is dead, throw it or dispose it. They cannot be recharged. They cannot be recharged. Correct? So in this electrochemical reaction, whatever is happening in these batteries are irreversible reaction. They are not reversible reaction. So initial cost is less. For these batteries, initial cost is less. Generally, battery you buy for the clocks or the watch or the torch, these are all non-rechargeable battery, primary battery. The initial cost is less as compared to secondary battery, right? And these are useful when a long period of storage is required. You keep this battery for a long time, then use it. The duration of the storage is more, and the application which requires small amount of current for longer time. Current for longer time. So here time is more, it lasts for longer, but the amount of current it gives is less, right? So a good example of this is Leclanche cell, and they are invented by the French scientist Georges Leclanche in 1866, right? So in this case, what he did was he replaced the carbon electrode which was there in the, he replaced the copper electrode which was there in the galvanic cell with carbon in galvanic cell. That's what he did in 1866, Leclanche cell. We'll study in detail about this cell now. So as I've told, this was invented by Georges Leclanche, 1866. This is how it looks, 3D view. So if you see what is here in this is a carbon, and this is positive charge, and this is my negative charge, correct? And this is zinc as usual. We have not replaced the zinc, only the copper has been replaced with carbon. And typically this is my glass. You see is a glass here, and this is my porous pot. Porous pot, I'll tell you why it is used. And here we have this powdered manganese dioxide, powdered MnO2, right? It also has some granulated carbon. Right? This is generally used to prevent polarization. I'll write here. Prevent polarization. I'll discuss about this also. Correct. And then we have here, we have the pink one is the saturated aqueous solution of ammonium chloride, NH4Cl. So in the real time, if you see NH4Cl, it is colorless, as we have just shown pink here. This is NH4Cl, and that's all. Correct. So if you see this carbon rod, this is in a porous pot, and this has this powdered MnO2, right? So here my electrolyte is NH4Cl, that is my electrolyte. So let me write here, this is my electrolyte. And my electrodes are carbon and zinc. 2 electrodes. Correct. And this mouth of this whole jar is sealed. That is actually sealed. It is sealed. The whole thing is sealed with a pitch. There's a pitch here. It is sealed with a pitch so that the NH4Cl should not come out of the jar. Correct. And please note, NH4Cl is a very strong electrolyte. Now let's see the reaction happening. See, this has NH4Cl. We know that NH4Cl is a very strong electrolyte. So NH4Cl will immediately break into NH4 plus and Cl minus, right? There will be a lot of NH4 plus and Cl minus ions here. So I'll put them Cl minus, right? Cl minus, 3 Cl minus and 3 NH4 plus. Okay, so we have Cl minus, so many Cl minus we have, and we have so many NH4 plus. Now if you see, zinc has tendency to lose electron, correct? We have seen that. Zinc wants to go to Zn plus 2. So what zinc will do, zinc will combine with this Cl minus here, it will become ZnCl2, and this it will lose 2 electrons. Correct. Now that means there will be electrons here because zinc has reacted with chlorine and become ZnCl2, and the ZnCl2 will be somewhere here only, but there are 2 electrons here. More zinc will react and more 2 electrons will come. So similarly like this, we'll have more electrons here. Since there are more electrons in this electrode becomes negative charge. The zinc electrode becomes negative charge. Now NH4 plus, it moves to carbon dot. This is the porous one, it can move to carbon dot. Right? So now NH4 plus will take electron from this carbon dot and will become NH3. And if you see, some hydrogen gases evolved. So with this, there is a deficit of electron here in this carbon. So carbon becomes positive charged. So my cell will work. Now again, since there are a lot of hydrogen here, because this reaction is happening here, right? If more hydrogen comes here, then polarization will happen, because this electrodes will absorb this hydrogen. Correct? And with this polarization, the battery will not work properly. So we want to avoid this polarization. Correct? So what we do is, we use MnA2. This hydrogen gas, whatever is there, will be oxidized by MnA2. So hydrogen gas, if you see, when MnA2 reacts with this, it forms a little bit of water and Mn2O3. Right? It gets oxidized. And thus polarization is prevented. If you see, the role of MnA2 was only to prevent polarization. That's all. So pretty easy equation. I have NH4Cl, it easily breaks into NH4 plus and Cl minus. The Cl minus comes near contact with zinc and they react. Zinc becomes Zn plus 2. This reaction happens, zinc with Cl minus, it becomes ZnCl2 and 2 electrons are released. So this zinc electrode has lots of electrons. It gets negative charge. When connected to the circuit, now there's a deficiency of electrons here. How? So how it is done? This ammonia NH4 plus comes this side, react in this carbon side, right? It gets the electron from this carbon, because the moment you connect with the circuit, right, you get the electron, actually electron flows. The same electron is flowing through the circuit. And let's suppose there's a bulb here. It glows, right? Same electron comes here by the circuit, and these electrons are used by NH4 plus now to give ammonia and hydrogen gas. And then this hydrogen gas will create polarization, and this hydrogen gas may be absorbed by this carbon electron and this may not work properly. So we have this MnO2. So what MnO2 will do? It will react with this hydrogen gas and will convert this to water and will prevent polarization. Correct? The next. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.